Good morning, ma'am. I'm Khushi Srivastav, and here I am to represent my model. So, the topic of my model is properties of magnetic field lines. So, here is a diagram of magnetic field lines. So, there are some properties regarding magnetic field lines, and one of those are the direction of magnetic field line is from north pole to south pole outside the magnet and from south pole to north pole inside it. Thus, it is in the form of closed curve. This means we can see that in this diagram, magnetic field lines are emerging from north pole to the south pole. We can see the direction. This is from north pole to south pole outside the magnet, and same way from south pole to north pole inside the magnet. Hence, it is completing the closed curve. Now, second point, the tangent drawn at a point on the magnetic field line represent the direction of magnetic field at that point. So, in this diagram, there is a tangent. We can see here, this is the tangent, and this tangent will display the direction of magnetic field lines. This tangent drawn at this point, drawn at the magnetic field line, will for surely describe the direction of magnetic field line. Now the third point is, two magnetic field lines never cross each other. But if this happens, the two tangents drawn at this intersection would represent the two directions of magnetic field line at a point, which is impossible. It means we can we discussed in the second point that tangent drawn at magnetic field lines represent the direction of magnetic field lines. So if the two lines, we can see this diagram, if the two lines will intersect at a point, and when we'll draw the tangent here, then the tangent will display two directions, which is impossible for magnetic field lines. Or we can say that when we will place a magnetic compass, then needle will have to display two directions, that is impossible. Now we have fourth point. The density of magnetic field lines at a place is directly proportional to the intensity of magnetic field at that place. This means, in this diagram, this sentence means that where the intensity of magnetic field is maximum, where the intensity of magnetic field lines are maximum, there the density of magnetic field will also be maximum. Now we have fifth point, the last point but not the least one. The magnetic field lines of a uniform magnetic field are parallel to each other and are equal at distances. This means the lines at uniform magnetic field are parallel to each other, means they have equal distances. They are parallel to each other till the whole of their journey. They will be parallel to each other. So in this project we totally discussed 5 points, and so those 5 points are: first is magnetic field lines emerges from north pole to south pole outside the magnet and from south pole to north pole inside the magnet. Second point is, the tangent drawn at magnetic field lines represent the direction of magnetic field lines. The third point is, two magnetic field lines never cross each other, and if this happens, then the tangent will have to display two direction, which is impossible. Or when we'll put a magnetic compass over here, so the needle present in that magnetic compass would have to describe two direction for the magnetic field, which is impossible. So, and the fourth point is, the density of magnetic field lines at a place is directly proportional to the intensity of that place. So where there would be maximum lines, then there would be maximum intensity of that magnet. And the fifth point, the magnetic field lines of a uniform magnetic field are parallel to each other at equal distances. Means the uniform magnetic field lines, there the lines are parallel and are having equal distances throughout. So this is all my project. Hope it would be quite visible. Thank you, ma'am. Thank you so much. Sorry for the late.